And we need to move to the next activity, which is the session 6 on literacy in astronomy. And this session will be conducted by Robert Hollow. Robert, are you there?
I'm here.
Okay, so now you are the master of ceremony.
Thank you very much, Beatrice. So we have 5 speakers in this session, each of 10 minutes, and I'll give them a warning after 8 minutes. We'll then have 10 minutes for questions at the end. Please put them in the Q&A. So our first speaker is Franz Kerschbaum from Austria.
Hello from Vienna, Austria. I will tell you about Herschel and the invisible end of the rainbow. I did this research and outreach and educational project not alone, but together with my former PhD students, Magdalena Brunner, and we received significant funding from the Austrian Science Fund, the FWF. I hope you see my presentation well. Let's start with some history. In 1800, something very special happened. While studying the heat and colors of the sun, Wilhelm Herschel discovered more or less by chance infrared radiation with his spectroscopic experiment already in 1800, as I said. So in principle, he was measuring with simple thermometers how much heat is within certain color ranges. So he was measuring the temperature of areas on the ground, on tables for the temperature. And he, of course, was comparing this temperature with regions on the table that was not illuminated by light to have a comparison temperature. And more or less by chance, as I said, he pointed the thermometer to a region next to the red, which was dark, not illuminated, and it was clear, obvious for him that this region was hotter than the others, so there must be something invisible. And this was the first invisible radiation that was not pure magic, as all the things before, but could be probed in a very systematic way. He did optical experiments, reflections, and so on. This finding was only followed much later by other kinds of invisible light, namely, for instance, the radio waves in 1886 or X-rays in 1895. Today, infrared light is widely used and, of course, in technology and science. Herschel was not working alone, but he was working in a team together with his sister Caroline. She was starting as his assistant, but later on she published independent papers on comet stellar clusters. And from 1787 on, she got even paid. And she was the first female researcher getting paid for her work by the Crown. In 1828, she received gold medal by the Royal Astronomical Society and even became an honorary member later. Our outreach project was thought to complement our research done with ESA's Herschel Space Telescope, where we contributed science and also technical components to one of the instruments. And we thought a historical perspective on this discovery is something good for outreach and education. We wanted to show also experiments, and very important, we planned to feature Caroline's Herschel's role as a role model for women in science, and also to show that teamwork is important. And we have chosen a quite broad range of means to communicate, from art to experiment. So the first step was, of course, to redo the experiment itself. It turned out to be quite complex. It was not really easy to repeat it, because the changes in temperature with such a simple setup are only a few tenths of a degree Celsius. And that's not that easy to measure. So we were quite impressed what the Herschels achieved that long ago. First, we thought we will use this experiment as a giveaway experiment to kids, for instance, but it turned out to be complex and not too easy to reproduce. We were successful, but it was not that easy. So what did the Herschels miss at that time? Today we have modern infrared cameras. So we also did experiments with an infrared camera that we can use, for instance, in school outreach. And we made these pictures where you see the rainbow of the normal from the spectrum of the sun. And if you overlay this image of the rainbow produced by the prism with a thermal image, you see immediately that the temperatures are higher in the dark area next to the red part of the spectrum. So nowadays, it's very easy to show that the significant part of the energy that we receive and is split up by a prism is in the infrared region and can be imaged by that way. So we use this camera a lot with our work with kids and at science fairs, and show them how different the world looks with thermal eyes. You see here a car or the kids standing and doing their work, and you see Magdalena giving the camera to kids, and they experiment themselves and see how different the world looks like. It's really fun and motivating to do your own research. But that was not everything. We used this camera also as the star in several science fairs and outreach events. For instance, in the course of the Dance for Science event, that was a worldwide event during the March for Science, we streamed the dancing events in the infrared. And also, of course, I'm coming from Vienna, we have balls. The Viennese ball for science was also used to communicate infrared research. And we streamed out of one of the ballrooms, and you see the dancers here building a line, and we had a hottest dancer contest where we could communicate how interesting infrared radiation is. And of course, next to these ballrooms, we had some displays where we showed the science that can be done with infrared radiation. So an interesting mixture. We started at the beginning to have some hands-on experiments. I told you already, with spectroscopy and so on, and we built aha boxes called jenseits des rainbows, so next to the rainbow, with cartoons inside. You can do hand spectroscopy, you can do spectroscopy on the sun, you can build everything yourself. You can color books, you can spin a color wheel. And we developed these experiment boxes in Vienna, and they were produced together with our partners, the Indian Manthan Educational Program Society, in a social enterprise in India. So this has also this side component, and these boxes are available both in German and English as all our outreach and educational material. We produce several podcasts, clips, movies now in COVID-19 home office and home education times. We produced little videos. Teachers can show to the kids online how infrared radiation works, how you can, for instance, measure the temperature of two glasses filled with different temperature fluids and so on. So this was quite interesting, and you have many downloads available on our websites. I will tell you later on. Of course, the highlight, I would say, the outreach highlight of our educational project was a theater play. We wrote together with some authors a theater play on the Herschel experiments, especially
2 minutes,
on this,
Franz.
Yeah, on the Herschel experiments. It's quite entertaining, and the play is done in a way that the scientists themselves can play it. Yeah. We did it at big science fairs and exhibitions, and you see here Magdalena and myself, costumes as the Herschel siblings, and playing this. And after this, we gave some talks on infrared radiation, used the infrared cameras for the kids and the other audience to experiment. You can visit us, you can download all these materials, for instance, the theater script, also in English and German, from our web pages. You can contact us if you're interested in the aha boxes. Our Indian partners are happy to help you in this regard. You can build your own aha boxes. They turned out to be quite nice as a giveaway. They turned out to be quite nice to give it to school classes. The teachers are very happy to use them for experiments. And in the meantime, we have such boxes also for other topics, for instance, in biology or the moon landings and so on, astronomy experiments and so on. So visit our webpage. We are happy to inform you. And thanks for listening to my talk.
Thank you very much, Franz. Perfect timing. So if we'll move on to our next speaker now. And we have Sara Ricciardi. I hope I've pronounced that correctly, from INAF in Italy. So Sara, if you're there.
Do you see my screen?
We do, yes.
Okay, great. So, okay. So I'm gonna talk about Destinazione Luna. I'm working at INAF, actually. I didn't see that, in Italy, and the talk is it's on behalf of actually a large group of people that I need to acknowledge. So Destinazione Luna is a large and various outreach program, from plein air and movie night with 5,000 participants to cozy workshop with kids, the Moon camp that we run with 20 female teenagers through the year, and educational activity with full classes, so kindergarten children and primary. And everything was done in collaboration with Cineteca di Bologna and Amelie, that's a cultural association based in Bologna. And now I will talk just about Destinazione Luna Kids, so the educational activity with full classes. I'm just going to flash this slide to let you know our models in the past and people that we look at today. So, for example, the Tinkering Studio at the Observatory in San Francisco and the Lifelong Kindergarten Group. And for us, it's very important, of course, the work of Seymour Papert, that as constructive is centered the attention on the learner and this process, but also claim that the learning happens more efficiently if the learner is engaged in building some physical objects that can be physical or virtual. So, okay. So of course, this idea resonates on me as a scientist also, because it introduced the concept of cognitive artifacts that are objects or devices that facilitate the learning process and that people need the same way a builder needs building materials. So those concrete products have to be designed, shown, discussed, examined, investigated, and also admired. And I'm wondering what is a satellite for astrophysics, or for example, a radio telescope. This one is the antenna of ALMA. And actually, I really love this picture because we are also building a band 2+3 receiver right now. So, but all this stuff are just a giant and wonderful cognitive artifact that actually we use to understand our world. So this pedagogy really resonates with me as a scientist, not just as an educator, because our community work like that, and I really hope to provide the chance to let kids understand also how our community works, not just the literacy related to that. So all the resources are online. And actually, the resources natively are in Italian, and then together with other people at INAF, Giuliana Giobbi, for example, we translated in English and French. And I think this is the perfect audience to ask if someone wants to translate in Spanish. Of course, I will be happy to provide everything, because it will be super nice to have it in Spanish too, and also other languages. And we got filmography, bibliography, a booklet for both educators and parents, some activity about drawing the moon on exercise book, some exploration with the Lunatario, some preliminary activity we designed together with the kindergarten teacher, that has preliminary for very young children, and then also the moon and 3D printouts for the 3D printer. So Destinazione Luna Kids is organized in 3 moments. So a first and welcoming approach with the picture book, and we read the book and we chat with children. Then the Lunatario exploration, and finally the movie theater experience. Depending on the age and number of pupils, we split the class into groups, half working at the Lunatario and half working at and half watching the animation. So the classical definition of STEM as science, technology, engineering, and math used to group together those considered hard science has been often replaced by the acronym STEAM. So A is for art, is basically represent the need to use those disciplines as a true form of self-expression, and so self-determination in your own learning. I believe science itself can be a powerful way to express yourself, but definitely expressive language are less rigidly coded and are more immediate, so they help. Another reason why not to segregate STEM discipline from art is the audience. Children are still not so affected by the useless atomization of knowledge in disciplines, and they often learn in a learner-desk fashion without worrying too much about discipline. So recently, with the proposal of STEM, we add one more layer. So R is for reading and writing, and advocates of STEM see literacy as an essential part of a well-rounded curriculum, as it requires critical thinking as well as creativity. This, of course, might be true, but we connected STEM and reading for other reasons, because in our previous experience, we found that using a familiar object, such as a picture book, can help to spark the initial interest through a familiar and well-known objects, and also will help to keep a very short psychological distance between the children and the scientist or the educator. So the picture book is, in our opinion, the perfect object of transition from a familiar and protected world to the realm of STEM, that for someone can be intimidating. We want to definitely avoid the feeling of wonder, of excitement that happen when people get to explore astrophysics will become a sort of psychological border. We believe, in fact, that this wonder is something that is not always positive for everyone in the classroom, not because those feelings are negative per se, but because children could feel they are not smart enough to be involved in such a wonderful but maybe distant idea. So, okay, I think I will flash this slide because I don't have time. And I'll show you the Lunatario itself. The Lunatario is a big octagonal wooden box with 8 peeping holes to visually explore a 3D printed white moon fixed on the ceiling with a fishing string. So in the dark, it would appear suspended. The facilitation of this activity is very light, playful, child-centered to allow a personal and meaningful discovery, and is based on the idea of building a micro-learning community where children can learn also from peers. With enough time for exploration, and this is actually really needed, children build the idea of the importance of the relative position between the sun, the torch, and the observer. We dig deep in this concept, allowing different solid figures in the Lunatarium when we prototype a 3D printed version of the Lunatario. And also, sorry, I'm a bit in trouble. You can, okay. And also we provide some craft materials to materialize concept and think a bit away from the box. For this purpose, we provided black cards and white pencils, so the children could choose to reproduce one or more moon phases. And this reflexive gesture was integrated as needed with new observation of light drawing, with an eye on the Lunatario and an eye on the drawing. With the youngest, I'm talking about 4 years old, 5 years old children. This was very important because the concept of right, left, up, down, dark, light might be not yet consolidated. So we observed that
2 minutes, Sarah.
Okay. The small moon sparkled new curiosity in children that immediately recall episode of moon observation, and they express the desire to observe the real moon again. Exploration of the Lunatario should be done together with the exploration of the sky through, for example, life drawing or drawing a moon journal. And then finally, okay, I don't have time for this one now, about the experience at in the theater. It's everything I said before about the picture book apply also for this for this idea. And the 3D printer Lunatario is a good solution to bring this idea in school because it's portable, cheap, and kids can make by themselves. They can explore with touch. They can explore different geometries. You can do the same with cardboard or light wood. And we choose 3D printing because in Italy, and particularly in our local community, we have a bunch of schools equipped with this 3D printer. And a variety of teacher training is currently available where the technical information of 3D printer is provided, but less resources and training is provided instead to illustrate the pedagogical possibility of 3D printing. So opening up this new technology could serve to construct knowledge and own it. So this is a slide with all the people involved also because I think it's very important to highlight different expertise, not just astrophysics, but we got a lot of teachers helping us and also people that are in visual education and young adults, literature and picture books and pedagogy. And actually, I think this is very important. And then again, my email, in case you want to have an update or you need more information, and the website where you can find everything from the print file to all the documentation of the project.
Thank you very much, Sarah. Bang on time.
Okay.
So now our next speaker is supposed to be Basilio Solís-Castillo. I don't see Basilio.
Oh, no,
hasn't
Robert,
shown up.
He's not here, so go.
Right, so we will move straight on to our speaker, our fourth speaker then, Gary Hemming, from the European Gravitational Observatory. So over to you, Gary.
Thanks very much. Just share my screen. Can you see that okay?
Yes, we can.
Great. Okay, so nice to be speaking to you all here today. I'm a British-Italian software developer at the European Gravitational Observatory and a member of the Virgo collaboration. And I'm also the technical manager. There's Virgo at the observatory in all its glory, and I'm also the technical manager of the Reinforce project, of which I'm going to talk to you today. So what is Reinforce? Basically, it's a project that receives funding from the European Union within the Horizon 2020 framework, under the auspices of the Science with and for Society program. And it's been designed with the intention of bringing large-scale research infrastructures and society closer through the means of citizen science. It has these goals, quite a broad set of goals. It aims to build a community of practice, to undertake an impact assessment of the whole citizen science online procedure, to develop a policy roadmap for research infrastructures in the future, and to do so by concentrating on key groups and working in an interdisciplinary way. Now, this goal will be reached through 4 online demonstrator projects, each in a different area of frontier science. So we've got gravitational waves, neutrinos, via the KM3 net detector and collaboration, the search for new particles at the LHC, which uses data from the Atlas detector, and a muography demonstrator based on the use of muography to understand geophysical structures. And we have a big advantage in that we are one of the partners in the project is Zooniverse, which is of course a very well known online citizen science platform, and they are embedded directly in the project itself. Now, on top of Zooniverse, we have the Sono Uno team, who are led by Beatrice, there at CONICET, and they are handling the whole sonification aspect of the project, because one of the key aims of Reinforce is to make our work as widely accessible as possible. Now, accessible not just in the terms of ticking boxes, let's say. So we are looking to make what we provide as accessible as possible, because we believe that that is the most effective way of us being able to reach our project goals. So accessibility, the idea of accessibility as being imperative for some, but important for everybody, an improvement for everybody. So and one aspect of this is the fact that all of our information, which is going to be provided within the Zooniverse platform, will be all our data will be represented in visual formats, but also in sonified versions via the Sono software. So there's a quick example of the work that Beatrice and her team have been doing within the project. Now, the individual demonstrators, we have one on gravitational waves. There you saw Virgo looking out into on the plain of the Arno Valley near to Pisa. And here we see an example of some of the data that we acquire via our data acquisition system. You know, we have thousands, tens of thousands of different channels being acquired at various different sampling rates, and within that data we have a lot of what we term glitches. So and we have to be able to identify these. So what we're going to ask citizen scientists to do is to help us classify these glitches via both visual and audio representations of them. Beyond the first demonstrator, we have, as I mentioned before, the KM3Net team, who are a team of more than 250 people based mainly around Europe, but also elsewhere in the world, with 2 different detectors, one in French territorial waters, one in Italian. And they have these fantastic neutrino detectors, which are dropped to the bottom of the sea, and they pick up all manner of bioluminescence and acoustic signals. And they're very good. The KM3Net team are very good at understanding the neutrino sources, atmospheric and cosmological sources, source neutrinos, but they also, via these detectors, pick up a vast array of signals from surrounding wildlife, so from mammals living at in the vicinity of the detectors and so on. So they will ask citizen scientists to help them to classify and characterize these spurious signals for them. Beyond that, we have the team at the Institute for Accelerating Systems in Greece, and they are using first simulated and eventually atlas data to first train and then bring citizen scientists into the particle identification process. Beyond that, we also have the 3 separate stages of their procedure, and beyond that we have the muography work package. Here you can see the diaphane detector located at a tumulus in Greece that was at the Apollonius tumulus in Greece, which was collecting data in 2018. And citizen scientists within this demonstrator will be able to train, first of all, in understanding how muons pass through the detector across 3 different dimensions, before moving on to be able to help to identify new patterns and to help to characterize the data that this team has been collecting over the years. Underlying everything, we're building the project on the principle of participatory design, and this is being pursued by an organization in Greece, EA, Elino and Germaniki Agogi, who are involved in a series of workshops within which these so-called visionary workshops, within which people are able to contribute to help to shape the development of the project and its general design.
2 minutes, Gary.
Thanks. Beyond that, we have a series of dissemination activities which are managed by another partner, Trust IT, and they're developing a lot of webinars and publicity campaigns and so on. There you just see a few examples of some of the things that we've been doing. They've put together a very nice website. We've organized, as I mentioned before, webinars based on building on an episode of The Sky at Night, in which some of the project partners were involved, Beatrice's work, and Wanda Diaz-Merced, who's also in the project as well. And so we've built webinars trying to dedicated to these kind of topics to grow what we're doing. We've got a lot of experience within the reinforced collaboration of making, of putting together so-called accessible events and making already what we produce accessible. And we also there's a strong theme of the involvement of the arts in what we're doing. Just a couple of weeks ago, we had a workshop dedicated within under the heading of the European Researchers' Night, organized by EGO, dedicated to this listening to the cosmos with science and art. So all to do with the sonification of data. Well, we have a very complex evaluation model as well, which is being carried forward by a team in Vienna, in Austria, ZSI. And so hopefully, as we move forward over the coming months, we aim to have these demonstrators online by the middle of next year, and hopefully we'll then really be able to look to produce some results.
Great. Thanks very much, Gary. Right on time. So pleased to say our previous speaker has managed to get online. So Basilio Solís-Castillo. So Basilio, if you'd like to share your screen. And you've got 10 minutes, and I'll give you a warning at 8 minutes. So thanks.
Thank you. Thank you for the opportunity to be in here and to talk about something that I find really, really important. So my name is Basilio. I'm from Chile, and I will talk about the impact of language, culture, and heritage on the way we learn and communicate astronomy. First of all, as a Chilean, as a Chilean, I was born in a place very, very interesting to learn about astronomy. So for me, astronomy was always an option to study or to make my future career studying astronomy. But the thing is, from Chile during those days, was a bit difficult to understand like what was to study astronomy like as a career. So normally in the environment, in the world we live in, normally there is a predominance of English and the Western culture in very different things. For example, speaking a language that is different than from English was, and sometimes still is, disadvantage to learn astronomy, because most of the material, most of the textbooks are the most important ones are in English, and of course the publications, so the papers we read normally for doing research, also they are in English. So speaking a non-English language always affects, in this case, to learn like something like astronomy. And in Chile, a couple of decades ago, astronomy and astronomers were considered something like another hemisphere science or profession. So was kind of a rare to very strange to find on the street the possibility to have like to talk with an astronomer during those days. And as a developing country, of course, the main interests of those countries are always focused on economy, and leaving education and science behind for a long time ago. So that was one of the things. And other was like I was talking about the textbooks. So when I started to study astronomy, it was difficult to find something in Spanish, of course. Was most of the things were related to English. Another thing, they were focused on northern constellations and stars. For example, the Northern Cross, the Big Dipper, Polaris, Vega. So when you find a textbook, and later you start to read, you always find these constellations, these stars, but they are from the northern hemisphere. So some things like Orion, from the southern hemisphere, is you can see it upside down, for example. So it was kind of difficult to relate to these things you can find in a textbook. And from the southern hemisphere, most of the constellation you read on the literature was difficult to find. So they were mostly unknown. But during the 60s, in Chile, we started to have like a couple of observatories that were installed for the first time. So we started to have like this change of environment. So we had the possibility to meet a lot of astronomers. So and starting to get in touch with astronomy other than just magazines and television programs. So my place in this story, my contribution started to work in the planetarium. So when I finished my master, I started to work in a planetarium, like a mostly outreach institution, and getting in touch with people, I find out that there are other approaches to astronomy. And working in an exhibition called The Universe South of the World, Our Celestial Heritage, we started to find out that there are a lot of astronomy knowledge coming not from the Western world, was coming from other regions, in this case from the indigenous populations of the Chilean First Nations. And so we rediscover like a rich culture around astronomy. So a lot of traditions, beliefs, and stories. And this came up like in a time when in Chile starting to get in touch with a lot of indigenous traditions. So there was like a growth in interest of the society to get in touch with the indigenous traditions and indigenous population. So now, for example, we have like the New Year's, the indigenous New Year, that is in June, normally for the summer solstice, and we celebrate like the New Year nowadays. So that's the way the things have changed in Chile, related in relation with how we see our indigenous population and indigenous tradition that now we have. And why I'm talking about that? Because in contrast with the Western Hemisphere, the Andean culture, so from the northern part of Chile, they created, for example, constellation not using stars. They were using the dark region of the Milky Way, for example. So the constellations, the inhabitants of the Andean region was related to the dark regions, so the no presence of stars, instead of uniting stars like forming like a figure. And these people, they use like common animals in the Andean area, like llamas, birds, foxes, and snake, in order to like to share, to explain the universe they were living in. So they started like these findings. There were like a lot of people really interested in order to rediscover this ancient culture. So for example, we have the Jacana, that is the celestial llama that is in the sky, and on the left side you can see like the the drawing of this llama. So they use this part of the Milky Way, the dark regions of the Milky Way, to depict this celestial llama. So, but also we find out that there is like a very interesting connection with the sky through the ages. So we found some monuments, some petroglyphs, and geoglyphs on different parts of the northern part of Chile, and they were showing the same. So they were using the summer solstice, so they were talking about the change of seasons, and they used this change of season and these alignments to build their calendar. And the petroglyphs and the geoglyphs, they were using to explain what they were watching in the sky. So they were reproducing what it was in the sky. And
2 minutes.
Thank you. And well, Chile today is a very different place from like a couple of decades ago. So we had like exponential growth in astronomical infrastructure during the last decades. We have now a lot of astronomy research groups like working in several universities, science institutions, and now the astronomy has positioned itself as a topic of interest for Chilean society and government. Nowadays, it's not really strange to see one astronomer talking in the television. So, and now, I could say the last decade, we had like a very, the cultural astronomy. So the culture around astronomy has become a relevant subject to study. And a new generation of Chileans have grown knowing about our unique skies, and that is perfect for astronomical observation. And nowadays, to become an astronomer is not so strange as it was like 20 or 30 years ago. Thank you for the time.
Great, thank you very much, Basilio. And it's great to see, as somebody here in Australia, it's nice to see some other southern skies. I point out that the llama in Chile becomes the emu to many of our indigenous astronomers here in Australia. So our final speaker for this session will be Sutapa Chattopadhyay. I'm sorry if I've pronounced that incorrectly. So if you'd like to share your screen, please.
Yes, I'm trying. I'm starting in a moment.
That's right.
Can you see my presentation?
Not yet.
Let's try again. Just a moment. I'm sharing my screen. Is it visible now?
No, we can't see it. Oh, hang on, something's coming through now.
Yes. I think now it's visible.
Yes. Yeah.
Thank you.
Yeah. Great.
Hello, I am Sutapa Chattopadhyay. I am from Institute of Astronomical Studies, West Bengal, India. I am a primary school teacher and an amateur astronomer and educator. I'll be talking about literacy in astronomy in Indian villages. Let's introduce our institute in this prestigious platform of IAU. Institute of Astronomical Studies conduct workshops for primary and secondary school students with low cost or no cost materials. In their classrooms, students are able to make star trackers, pinhole camera, sundial by themselves. In the evening, they observe sky with our portable telescope. We have arranged a short course, 6-module course, to initiate astronomy and motivate them for science and technology careers. For the teachers, we are arranging online teacher training courses and 2 workshops in 2021. The object of this training is to motivate students through them. In a pilot project, we select 6 schools and till now we get average response in this pandemic situation. Let's see the present scenario of astronomy in Indian villages. In Indian villages, the life of a villager is closely related with astronomy, as Indian culture is saturated with astronomy in many ways. Indians have many occasions, rituals, etc., which have connection with the lunisolar calendar. But there are some problems also, which inhibit us to say that they are now astronomically literate. The first problem is that problems with the students, and the second problems with the teachers, and the third one is problems with the general public. Some problems with the students are they only listen to the description of the sky in their environment class, but they do not learn to observe the sky. The second problem is that they have not ever seen a telescope. And last of all, the word astronomy is unknown to many of them. So to initiate their motive on science and for taking up future STEM career, it is important to give astronomy literacy by a class-wise short astronomy course, which we are trying. To initiate astronomical literacy, they have to know about basic astronomical instruments. In India, astronomy was studied from ancient ages. Vedic literature, Indian epics are the proof of ancient Indian astronomical knowledge. In 7th century CE, Brahmagupta, the great mathematician and astronomer, dedicated a chapter in his masterpiece Brahmasputa Siddhanta for astronomical instruments. In 17th century CE, Swai Joy Singh constructed masonry observatories in 5 places in India, that is in Jaipur, in Varanasi, in Delhi, in Mathura, and in Ujjain. These observatories play an important role in astronomical literacy. Today, we are trying to develop an idea about primary astronomical instruments among the students. We have a plan to introduce telescope in schools, which are selected as the pilot project. It will be possible if we get sponsors. Now let's come to the problems with the teachers. Most of the teachers of primary and secondary sections are not familiar with astronomy. They do not handle telescope nor have the habit to observe night sky and have inspiration about astronomy. But they are expected to help the children to expand their imagination. So to enhance their skill, they should be guided with teacher training workshops, astronomy courses, etc. Let's develop an astronomy culture. Now, let's talk about astronomy for the adults. General people can think logically if they get knowledge of astronomy. It develops social psychology, scientific consciousness, and positive attitude. Popular lecture, workshop, seminars, visit to a planetarium, and heritage astronomical sites will help them to get literacy in astronomy. To develop an astronomy culture and scientific consciousness, literacy of astronomy is the epoch. On behalf of Institute of Astronomical Studies, we want to promote astronomy literacy for early child. Indian mothers play an important role to shape up the minds of their children. Bengali mothers sing a lullaby pointing towards the moon. That is, আয় আয় চাঁদ মামা টি দিয়ে যা চাঁদের কপালে চাঁদ টি দিয়ে যা. Thus they introduce their children with the sky and moon. Years later, with Saptarshi Mandal, that is the Big Dipper, and Kalpurush, that is the Orion. So we try to focus on the astronomy literacy of the mothers specially to incline their children to astronomy. A mother can influence her children like no other can, that we think. Our call is astronomy for all. If general public of different background get proper training on basic astronomy, society will be developed. Science and technology make a society scientific. Logical thinking will be developed with astronomy. To develop an astronomy culture, the literacy of astronomy is essential. Institute of Astronomical Studies, believes it from heart, and we say, observe the sky, expand the mind, enjoy the beauty, and celebrate life. Thank you.
Thank you very much, Sutapa. So we've got plenty of time for questions. I think we've had 5 all very different, diverse and excellent talks. So I've been trying to keep on top of the chat and the Q&A. I know some of the questions have already been answered, but I've got one here for Basilio. You mentioned a planetarium show, and Beatrice wanted to know if that was available for all, please.
Sorry, please repeat the question.
So that one was for Basilio.
Can you repeat the question, please?
The question was the planetarium show you mentioned. Is that available?
Okay.
Yeah, it is. Well, nowadays for the sanitary situation is closed, but it is possible to. We have this old card size projector from the 70s, and is now is united with all that digital system. So I think it's really interesting experience to go to this planetarium.
All right, okay. I'm just trying to see, we've got a few others here. So one of the questions came up about your talk, Franz, stressing the value of the history of astronomy, but it also then mentioned the fact that astronomers, well, a lot of the, hang on, just trying to get it, here it is, the historic observatories are being forced to redefine themselves, and so they're losing that knowledge as the staff move on. And I wondered if you've got any comments around that.
Yeah, we had over, I have to say, over decades the discussion, if we leave the observatory, it would be better to go to a central campus area together with other sciences and so on. And in the end, of course, it turned out that it's better to stay here, and we got the observatory renovated because here we can combine. And of course, this was the result of many exhibitions and public events with thousands of people visiting our big observatory, that we can stay here and got it modernized here. So it's not completely finished yet, and it's a constant struggle, of course, with the historical instrumentation and so on. But in the end, we could convince the university that such a big observatory is a value by itself, because it shows this historical perspective. And as I wrote in my answer, you know, we have books of all authors. We have first editions of Kepler, Copernicus, and so on here, and display in our museums and so on, and old instrumentation. So the combination of modern science, and you know, I'm doing space projects. That's most of my work is building space telescopes. This combination is a good one, and it attracts the general public and show that we are standing to cite something on the shoulders of giants.
So I think that leads into a couple of themes I'm sort of picking up on. So I know, Basilio, you were showing the spectacular Atacama and the culture in Chile there, and leads to the idea also not just an awareness of, I guess, traditional or indigenous sky cultures, but also the potential there for astrotourism in much of Chile, and also with your talk, Sutapa, about the rich historical astronomical culture across India. So I wonder if either of you have a comment you'd like to say about that.
Well, my comment is connected to the how to reach like society, or how to do astronomy outreach, you know. So talking about like indigenous tradition and indigenous culture, we have this connection with people that is easier for them to understand, for example, nowadays astronomy. So I think to rescue this celestial heritage we have, is helping us to reach more people in order to they can reach science in a different way, in a different approach, and of course they are more interested, like in science, like in other cases. So I think it's a win-to-win situation. So we learn from our culture, and also the people get in touch like more closely using these older traditions we have.
Sutapa, do you have anything you'd like to add there?
Sorry?
Would you like to comment on the sort of interplay between culture, history, and traditional knowledge?
Okay, I want to comment. My experience is that the indigenous people have a much knowledge, something they know that we do not know, and by practice they carry forward this knowledge to their future generation. But nowadays the what can I say, the tradition is lacking a bit, and when we are attracted to modern science, many times we are ignoring our traditional knowledge. I think that's not good for us. We should try to gain something also from our traditional knowledge and from traditional peoples, that I think. And so I said the mothers are the great teachers. They can, when a mother is knows astronomy, she can train her child to see the sky. As far as I know, that all Bengali mothers can do this with their children, and if they can do this, they can also inspire them to take future astronomy courses, astronomy classes, and do something big in astronomy. That I think.
Okay, thank you. So Gary, oh, hang on, everything just went strange. Come back there. You were showing us, I guess, the other end of the spectrum in, Virgo, gravitational wave observatories, and neutrino detectors deep in the ocean, and obviously then using citizen science. I was wondering, how do you go about evaluating the effectiveness or the engagement of, say, Deep Hunters or one of the citizen science projects?
Okay, well, what we're doing in Reinforce is, I mean, it's a well-known phenomenon in these kind of online citizen science programs that you will have, when a program is launched, you will have a significant take-up, but also a very significant drop-off. Because inevitably you end up with a kind of rump core of users or of citizen scientists who form your community, and then do all of the work, basically. So what we are doing in Reinforce to try and help understand this and understand how we can retain people's interest is we have this pre and post sort of staggered evaluation process where we will be we're already building a community of people even before we go with all of the demonstrators online in the middle of next year, and we're already sort of pushing people, not pushing, let's say, but interacting with people, asking questions that we can come back to them again and again and see, if even people who drop out of the process and so on. So it's not straightforward, but that's what we're going to try and do.
Yeah, I think, well, the Zooniverse certainly is a great structure for helping with that, and I was involved in Radio Galaxy Zoo. So Sarah, we did have a question for you. I think you may have answered it, but it might be worth sharing more widely. So Hugo wanted to know, do you have science theatre in your project?
No, actually, for the project, we work together with Cineteca di Bologna, and it's a mecca for cinephile. It's a wonderful place. They have actually a real movie theater. Actually, they have I think 3 movie theater. So we use the facility, but then we start to work with school. So we brought also the projector at school, or maybe we use the screen that they have at school. And the project starts in September, but then we have to dismiss very quickly because of the COVID. So I need to document, I need to do much more work that now is impossible because actually children cannot also share the materials. So it's very, very difficult to do basically anything. Yeah. So.
Well, thank you. Look, I think we're just about out of time. So thanks to all of our speakers, 5 wonderful and diverse talks. And I know I've got lots to go and explore and follow up on. So with that, I'll hand back over to you, Beatrice.